We're going to look at an example of how we use Venn diagrams to help us solve some problems in probability. We've got a scenario here. A card is selected at random from a pack of 52 playing cards. A is the event that the card is an ace, and B is the event that the card is a diamond. So we can see here the sample space, and this contains all 52 outcomes. We can see the closed curve here, and this contains all of the outcomes of event A. In other words, that the card is an ace. So this closed curve will contain 4 outcomes because there are 4 aces. Whereas this closed curve here, B, is the event that the card is a diamond. So this closed curve will contain 13 outcomes. And so when we're using Venn diagrams to solve probability problems, the first thing is to write in the various areas of the Venn diagram the number of outcomes. And it's always best to start in the middle and work out, for want of a better word, so at the intersections. Now this is the intersection of A and B. In other words, in terms of this scenario, when the card is both an ace and a diamond, and that, in other words, is the ace of diamonds, and there's only one ace of diamonds, so I can write 1 in here. Now event A is the event that the card is an ace, and so there are 4 outcomes that it is an ace. Well, we've used 1 here, so to make sure the whole thing sums to 4, well, this has got to be 3. And in a similar way, B is the outcome that the card is a diamond. Now there are 13 diamonds, but one of them resides in this intersection because it's the ace of diamonds, so we've got the other 12 here. So that just leaves this area here, the area where it is neither an ace or a diamond. Well, we know there are 52 cards in a pack, and that we've used 16 of them, so the balance is 36 here. So this is step 1. We've populated our Venn diagram, and we can now go on to use it to solve various probability questions. So for instance, you're asked to find the probability of A intersection B. In other words, if we look at it visually, that's going to be this area here, and I can see that is going to be just one outcome out of the 52. This is asking really, A intersection B is the outcome that the card is both an ace and a diamond, in other words the ace of diamonds, and that your knowledge may tell you that there is only one card out of the 52, so that's where we get the probability. We'll go on to look at another example. And the probability of A union B. Again, in plain English, this is the probability that the card is either an ace or a diamond or the ace of diamonds. And if we're to represent this on the Venn diagram, this is the area that we're concerned with, and we can see here that we've got 16 outcomes out of 52. And if we just simplify that fraction, we'll find that the probability is 4 out of 13. Next, we're asked to find the probability that the card is not A. And that will be this area here. and if we sum these totals up, the 12 and the 36, we can see that's 48 outcomes out of 52 total cards. In other words, 12 out of 13. And you may recall that we looked at another way, an alternative way of calculating the probability of not A. And that was to subtract from 1 just the probability of A, and that would leave all of the yellow area. And we get exactly the same result. Using Venn diagrams, it was easier just to do it directly, but there may be other situations when using this alternative definition is easier. The last one we're going to look at is the probability that is not A and is B. So it does take a little bit of thinking about sometimes, but we're saying that the probability that it is not an ace but is a diamond. So not an ace and is a diamond. So I'm going to basically show what area on the Venn diagram this represents. So not A is straightforward enough. All of this is not A in yellow, but that intersects with B. We need to see where that intersects with B. So we can only consider the yellow because that's not A. Where does the yellow intersect with B? Well, B is all of this, but the only place the intersection with not A and B occurs is this area here. So it's this area that we're looking for. So that's going to be 12 out of 52. We can simplify that. 2, 3 out of 13. So there's a 3 out of 13 chance that you're going to pick a card that is a diamond but not an ace.